Hey guys, welcome back to another episode of Simuleos. So today, let me go ahead and turn that on, turn this down. We are going to work on basically what we were working on yesterday. So after stream yesterday, Buttercake, who is currently in the chat, sent me a message on, Discord, and let me know that I had something wrong with the physics of the simulation I was running. I looked at it, he was completely and totally right. And I'll talk about that right now, and then we'll move on to the next bit of what we're doing today. So right now, the visualization that we're working on, the the movement of the asteroid through a bunch of planets, that is currently working, but I need to explain why. So let me go ahead and open up a terminal, git open Zernal, which again, stupid bug, I'm gonna have to run it, I'm gonna have to write something on it, then I'm gonna have to close it and run it again. I don't exactly know why this happened or how I figured out what the problem was to begin with, but hey, whatever. Hey Kranigan, and everyone else in chat, hey, thanks for coming in. Okay, so, what are we doing? Overall, we're working on the Verlet algorithm, or Verlet integration is also what it could be called. Integration. It is, of course, a force integrator, right? Okay, so let's talk about what the deal is here. So, we have the kinematic equation. So, it's x is equal to x naught plus the velocity, the initial velocity times time, plus, man, my t's and my pluses look exactly the same. I need to figure out how to fix that. Plus the acceleration times t squared over 2, plus the jerk, which is called b. It's a pretty jerk term. Actually, we're a jerk to the jerk term because we never really accept it into the kinematic equation. Regardless, doesn't matter. bt cubed over 4 plus, I'm going to say, order of t to the 4th. Okay, so this is what we've got in our kinematic equation. What we want to do is solve for x, right? So we want to solve for this variable over here. Now, x is, of course, a function of time, right? So what we do is we say x of t plus delta t is going to be equal to x naught plus v, this is correct, v naught times delta t plus a delta t squared over 2 plus b delta t cubed over 6, that's meant to be a 6, plus higher order terms. Okay, but then, thing is, we can't really solve for this because we need all these different variables, so let's do it another way. Let's do x of t minus delta t, one time step underneath. This is going to be equal to x naught minus v naught t, plus a delta t squared over 2, plus b of delta t cubed over 6, plus higher order terms. This is also minus. Okay. Did the music stop? Whatever, doesn't matter. It'll turn on in a second. Okay, so we add these guys together, we solve for x, this guy and this guy cancel out, this guy and this guy cancel out, and we get something like x, let me see, x of the next time step, so x of t, that's probably over my face, x of t plus delta t is going to be equal to 2x naught, minus x of t minus delta t, plus a delta t squared. Okay, so here's the cool part. The coolest part of this whole algorithm right here. We can find the next time step by knowing the current time step and the time step before with the acceleration, which of course will probably also be a function of x. And this gives us a local error of ot to the 4th because we've canceled out this ot squared term right here, or this ot cubed term here. So that's really cool. That's actually a pretty good error. However, new page 4, this is where it gets tricky. Okay, what if we actually need the velocity? It's a pretty good question. Everyone needs velocity for something. Like, what if we want the kinetic energy? Kinetic energy is going to be equal to 1/2 mv squared, right? You need the velocity. What are you supposed to do without the velocity? So, to find the velocity, you can use what's called the, forgive me if I'm mispronouncing this, Verlet method, in which case you just calculate the velocity like so. So you say velocity is going to be equal to x of t plus delta t minus x of t minus delta t over 2 delta t. There we go. You found the velocity. However, we're still not done, right? Because now here's the problem. What if the velocity is actually, hey Lordborn, what if the velocity is actually impacting? Like, what if the velocity is actually changing the kinematics of the system? Okay, Well, that's the exact case that we're going to run into in just a second. So we have planets, planet 1, planet 2, planet 3, and an asteroid here. We want to give the asteroid an initial kick, and this initial kick will be some sort of velocity equals v in it, right? Okay, so this means that what we need to do is modify, right, our movement based on some velocity. So we have to solve, hey Hemmert, the entire kinematic equation. X naught is equal to, x is equal to x naught plus v naught t plus 1/2 at squared, right? Okay, fine. So we can't really use the same Verlet method we did before. V, of course, will be somehow related to v naught plus at, and a is going to be some function of x and t. Okay, so this is basically where we're at. I'm going to have to pull out my actual notes in just a second, but the Verlet method turns into something known as the, ooh, I did not mean to write there, turns into something called the velocity. It's not the velocity algorithm, I'm sorry. The velocity Verlet method. Come on, Verlet method. And that's this here. It's basically just solving the kinematic equation as you would. No big deal. I think the exact order is x, then a, then v, something like this. It's usually not that big of a deal. However, one thing I have to point out here is the error term here is ot squared, right? So it should be called the velocity. I feel like maybe it shouldn't. So here we have the ot squared error, which means that all the advantages of using the Verlet algorithm to begin with have kind of been canceled out because we don't get that fancy t to the 4th error term that we wanted. Okay, now let's talk about what I was doing wrong the other day. Okay, gravity is equal to the force of gravity, let's do it here, is going to be equal to g/m over r squared. Like we said, we're actually looking for the acceleration, so f equals ma, and so the m's cancel out, and a is going to be equal to g/m over r squared, right? Okay, that's fine, not a problem. G we assumed was going to be 1 for our simulations, not going to be a big deal, so a is going to be equal to m over r squared. There's something I missed yesterday, which is that this is a magnitude. It's a vector or a scalar quantity. The vector comes in later when we put in r hat. Okay? So this means that if we have two objects, no, we're not going to discover gravity. Gravity is already existing, right? If we have two objects here and here, there's some sort of force between these guys, and these forces in some sort of direction, right? All vectors have magnitude and direction, right? I mean, if you've ever seen Despicable Me, you'll know Vector. He was a supervillain or something in that show. Whatever, it doesn't matter. So we have magnitude and direction. The direction is the r hat. The magnitude is m over r squared. Okay, so that's what we did. And the direction is, of course, your regular r over the magnitude of r. So that's what it is. Yes, that's exactly what I just said. Well, yeah, sorry, there was a 20-second delay. So we get this r hat by finding this, and I'll show you this in code in just a second. So again, for some reason, no, not for some reason, I just wasn't thinking correctly yesterday, and so a Buttercake came in and was like, hey, you're an idiot, and I was like, yeah, I'm sorry about that. I don't know what it is, but since I started streaming again, I've been incredibly rusty on stream. I need to get better, but that's okay, we'll get there. So let's go into the code. CD projects, scivl, which is a library that we're working on. And we want to go into vi source and aux functions, which is the auxiliary functions that we're using for this. This is really annoying to read. I understand that. So here's what we got. Man. Okay. We have here glm vec3 acceleration, glm vec3 radius. So these are going to be the radius vectors and the acceleration vectors. We want the acceleration vector. This final element here will always be 0 because we have no acceleration in the z direction. No, he didn't call me an idiot. I'm sorry. That was me paraphrasing. Okay. So then we have these double magrad and magax. Yep, that's the thing. We see the radius is equal to a position, right? So the position of the object minus the position of whatever the object is in space that we're looking for, right? So the asteroid and the planet. We say the magnitude is going to be equal to rad 0 times rad 0 plus rad 1 times rad 1, right? So it's just magnitude without the square root around it. And then we say the radius is going to be rad 0 divided by mag rad 1 divided by mag rad, and 0. Easy enough. The magnitude of the acceleration will be the mass, which in this case we put in the third position because we don't need a z coordinate here. We divided that by mag rad, and here we are. But I did. Thanks that you're a fan. Appreciate it. And that's what we got. So if we run this, scivl, what do we want? No, I need to get in the right directory. CD projects, scivl. There we go. And we run scivl, and it should be s-verlet. We should get an object that kind of floats towards the most massive object there. Now here's one thing I want to point out. Hey, that's your fan. If I didn't say hey to someone, just let me know. I'll say hey to you. Okay, so let's do vi source distributions. And what I want to do, I want to go down to Verlet parameters. Okay, here's where we set all the parameters. So just to show that this is kind of sort of working, what I want to do is change this to 1. This is the mass of the upper right hand block, and change this one to 10. So this is the mass of the lower lower left hand block. So we're going to write that, go over here, make it, and give it a second to do its thing. And you'll see that the object moves slightly differently now. It just goes straight down there. Now, one thing to point out, let's just go ahead and Control C here. We have a very strange, how do we put it, set of coordinates here. So the ball is clearly way too far out. It's like in our coordinate system goes from -1 to +1 in both the x and y directions. This is set to be, at this point, negative 2,641 and then 1371 in x and y. So whatever we're doing is wrong, but that's okay. I think I know one big problem that we can fix, and we might fix it today, we might fix it tomorrow, depending. There's a C out that I don't want to be here anymore, so I'm just going to comment this out just to save space. Okay, so now what are we doing today? Today we're going to change the method that we're using such that it is the velocity Verlet algorithm instead of just the Verlet algorithm. So the very first thing I want to do is, well, I basically just want to go in there and set it so it is the velocity I'm going to keep saying velocity, and I apologize for that. I'm not intending to, it just happens. Okay, so I'm going to put in the velocity Verlet algorithm. And from there, I'm going to basically input a command so that the ball doesn't move unless we kind of shoot it with the spacebar. So I want to kind of allow users to move the ball up and down and shoot it and stuff like that. So in the end, let me just go ahead and run this guy one more time. Well, let's make it, and then we'll run it. 1 second. Yeah, so now we'll run it. We have the ball kind of doing here, but I want people to be able to move the ball up and down a little bit, and then press the space bar to create like some sort of velocity gauge or something like that, and then be able to shoot it based on that velocity gauge. It seems doable, so we'll see what happens. Okay. Okay, so let's see what happens. We want to go ahead and change the acceleration type up here. So this means we have to do a couple things. Let's go into VI source, distributions. So for the velocity Verlet algorithm, which is over here, let's go ahead and pop it up. We're going to need, well, a velocity term, right? But let me go ahead and grab out my notebook real quick. Because there's actually 2 ways to do this, and it's kind of weird that there are 2 ways to do it, but there are definitely 2 ways to do it. Okay, so one is the easy way, and one is the hard way. The easy way is kind of exactly what I put down here. So let's go ahead and, let's see. That was the first page, so I guess we want to go to this page, new page before. Yeah, okay, that should do it. Okay, I keep saying new page before, but maybe I should be doing new page after. It doesn't really matter. Okay, so the velocity Verlet algorithm. Okay, so one way we can do it is this. So we do x of t plus delta t is going to be equal to x of t, which is the current time step, plus v of t plus delta, 1 second. Yeah, v of t, and then times delta t plus 1/2 at squared. I'm going to put a t in there, delta t squared, right? And then we say acceleration is equal to some function of x, which we have, the find acceleration function. Then we have, let's see, what else do we have? We say velocity of t plus delta t is going to be equal to v of t plus, I'm sorry, just v of t. I'm looking at two different formulas over here. I apologize for the confusion. Plus 1/2 a of t plus a of t plus delta t, delta t. Okay, so basically we average the two accelerations, and here we have here. Okay, so the other way to do this is going down here, a little bit more complicated. Let's see if we can fit it all in. We'll say v of t plus delta t. Oh, I'm sorry, t plus 1/2 delta t is going to be equal to v of t plus 1/2 a of t delta t. Okay, so basically we added half of this acceleration already. Then we'll say x of t plus delta t is going to be equal to x of t plus v of t plus 1/2 delta t, which is going to be this variable up here, times delta t. We will then say that a is going to be, again, some function of x, so I'll just kind of leave that out for now, same as down here. And then we say v of t plus delta t is going to be equal to v t plus 1/2 delta t plus 1/2 a t plus delta t delta t. There. So that's what we got. So we have two different methods to do this. Both ways we have to find the acceleration. And let me think. What do we have here? So it looks to me like up here we have to keep track of an additional acceleration term in addition to the velocity term. Down here, I don't think we need to keep track of the extra acceleration term at all. I think we can just use the terms that we have. So I think what I want to do, I think I want to do this method, even though it is one extra step. And I think I want to do that because it just saves a little bit of memory, even though it's not that important. It's just usually when you're working on GPU systems, which we aren't really at this point, but you want to save memory in every way possible. So this is fine. It's just one extra step, and I don't think we're going to run into anything computationally restrictive here. So that's what I think we'll do. Should be straightforward. So let's pop over here and let's add what we need to do. So let's go into Verlet par. And again, guys, if you have any questions, comments, concerns, anything like that, just let me know, and I will totally address it as soon as I see it in chat. Let's go ahead and add in an additional v3 map here, which is going to be our velocity. Luckily, this is v3, so this means that we have 3 components to it, an x, y, and z. So let's just go ahead and do 0, 0, 0 for now as the starting velocity. Screwed it up. 0, 0, 0. There we go. Okay. What am I doing? I know what I'm doing. I'm now going to go over here and I'm going to update this so it works the way we want it to. We don't need to keep track of the older variables, I don't think. Let me see. Right? So we say x of t. In this case. Yeah, we never need to keep track of previous time steps. So actually, we probably don't need this previous position at all in this case. And this helps out a good bit. Okay, so let's see. Where do we have previous position? Let's go ahead and paste here and say this is going to be our velocity. Change this over here to velocity. And let's see what we got. So we have dt. Everything else should be okay. Multiply acceleration, multiply position. Do we have to multiply velocity by anything? Let's see. Velocity. Yeah, we're going to have to multiply it by delta t. So I guess I'm also going to have a mult velocity in here. So where is that? Here it is. And we have a double position? Oh, never mind. This should just be, how do I put this? I guess it's going to be mult. Come on, velocity. And then we're going to add it back here. I guess just velocity. I did my good deed for the day. What was your good deed, Slayer Darth? Also, hey, thanks for coming in. Okay, let's go ahead and delete that. And we will say mult velocity. This is all ordered wrong. I apologize for that. And let's go our velocity here and our velocity there. Resolve someone's Angular JavaScript problem in like 5 minutes. Oh, good for you, man. There was it's always nice when people are like struggling with something and you're able to help them out. Yeah, I love that. I mean, I know it doesn't come along that often, but when you're able to just sit down and just work with someone on something and just give them a new perspective and then help them out with something, it's really enjoyable, you know? It was one of those things that motivated me to keep learning algorithms and stuff like that. Like the other day, a friend of mine was saying that his simulation was just too slow and he couldn't work with it any faster. And it was an ND simulation, and I was like, dude, you can actually use the bar inside algorithm here, and it will solve like all your problems without any real issue to your simulation results. He had implemented it and works just fine, you know? And that's the thing, like, it's kind of nice just to be able to sit down, talk to people and say, hey, I can help you, you know? It's something that doesn't happen very much in research, though. You have to kind of work with things on your own. Let me get a quick sip of water, I'm getting a little thirsty. Hey, Husky. Thanks for coming in, guys. Okay, so, yeah, okay, this is fine. So we have temp. We don't actually need to do this time. I think we can cheat. So let's see. We want, what am I doing? Translation vector is going to be part of positions minus here. Okay. Oh, we do have to keep track of the previous position. Definitely do. Okay, so let's go ahead and quit here. Open it up again. Gee, I think I wrote. I didn't write. Dagnabbit. I'm sorry. Okay, let me do it again. I was trying to get tricky. And I'm bad at tricks. Okay, so let's pop over here and let's say velocity 2. Yeah, it's like this streamer I'm following, Data Wars, said that he converted one of his friends from MATLAB to Python, and as a result, he was able to get much more work done. Yeah, well, so the other thing too is MATLAB is, it's one of those languages that is deceptively challenging, you know? You use MATLAB for a problem. It does everything you want it to do. It has all the plotting, everything's inbuilt. But then you have to use MATLAB-specific tools to do anything MATLAB-y, you know? So I'm not a big fan of using it. Yeah, it's great if you do only one thing. In fact, my entire lab uses MATLAB. But it's just, I get so frustrated when using it because all the tools I want to use, you know, the ability to create functions and classes and structs and all that kind of stuff, it's hard. It makes it difficult. It hides the computation from the programmer, in my opinion. So, because of that, I find it much, much more difficult to use than a language like Julia, which I find very enjoyable to use. But that's just my opinion. Let's do mult acceleration. Change this again to velocity. Let's see. Should do it. These guys should always be 0, so I think what I want to do is just go ahead and set all of these guys to 0 here, because I know they're going to be 0 anyway. I feel like I have Octave anyway, because I'm not a student. I feel like, hey, Fled from Nowhere, Gustorn, thanks for coming in. Yeah, so, yeah, hey. Yeah, I feel like, I don't know, I've replaced Julia with everything, like everything I would use Python for, or everything I would use MATLAB for, I've just replaced it with Julia, because it's easier in my opinion. But that's just because, like, if you want to use NumPy or something like that, you don't have to put, like, np.square root or something. It's relatively straightforward with Julia. But, again, this is whatever anyone's comfortable with, they can use that. I'm not languageist here, you know, whatever you want to use, you can use. Okay, so what am I doing here? Part of positions of index is equal to multiposition. What I actually want to do, wait, why did I multiply the position? I don't think I need to do that in this one. I think all I need to do is calculate the velocity first. So let's go down here and let's say velocity. Yeah, so let's do par dot. Again, I'm not a big fan of this, but v3 map. Oh, let's just do velocity. This will be easier. So we'll say velocity is going to be equal to its current velocity. So we'll just say plus equals 1/2 0.5 times acceleration times dt. That should be all it is. Then we go down here, and instead of using mult position, which I don't think we need anymore, so we can delete this, and we can delete it up here. I usually go with Python for one-off stuff. You have a lot more libraries than with Julia. Yeah, I think that's probably true. Maybe Julia was kind of catered to scientific computing, right? So it could just be that most of the projects I want to do can be done with Julia just because most of the people who use Julia also do the type of computing that I do. So that's probably true. Like, it's horrible for web stuff, you know? Okay, so we want to do plus equals, 1 second. Let's see if this works. And then we want v times delta t. So we want velocity dt. There we go. Then we want to calculate the acceleration one more time. So we find the Verlet acceleration up here. But maybe we should actually do it over here. Yes, we should probably do it over there. So we're just going to grab this dd, put it over here. And then after that, we need to grab the acceleration one more time. So let's yank. This is a pain, isn't it? It's probably okay to just put this up here for now, and then we'll talk about it in a second. Dang it. Verlet acceleration bar. There we go. What do we have? Gust run. Pretty much anything you want to do. There's some library which will at least help you if you go with Python. Too bad I don't really like the language that much. What did you do, Slayer Darth? Okay. v3 map previous p. Then we keep that in temp. This should be okay. Oh yeah, that should be okay. And then we just do this for the previous position. That should be okay. And then the last thing we need to update is the velocity one more time. So we're just going to do yank and paste down here. Yeah, since we have to keep track of the previous position anyway, let's just go ahead and do this way. So we're going to do... we have to keep track of the 2 accelerations. Anyway, no matter what we do, we have to keep track of the 2 accelerations. So let's just do dd here. Let's just calculate the velocity there. Actually, no, let's keep it up there. Let's just do dd there. And then we're just going to say plus 1/2, 0.5 times acceleration times... Oh, we have to do dt squared now. But it should just be mult acceleration because I don't think we need... we do, don't we? Oh my gosh, it's such a pain. Okay, so machine learning is your thing. Python is definitely the way to go. Yeah, so yeah, let's see. TensorFlow. Yeah, so that's true. All that's true. Okay, so I need some sort of multiplication function for these vec3s. Let's just go ahead and create that now because it's kind of driving me nuts now. And actually, I think it was in the right spot for it. So let's pop down here. Let's do mult. And we want to do, I guess we're going to say glm vec3. And then we're going to do double value. Right? Pop down here. We're going to say return glm vec. Yeah, vec3, we should do it this way. Yeah. And then we're going to say return, and then we're just going to return, oh my gosh, what am I doing here? Vector. Yeah, we'll just call it vec. Vec of 0 times vel, vec of 1 times vel, and vec of 2 times vel. That should do it. Go over here, write this, go here. Right, quit, and let's do it. You should actually no, it doesn't. Trust me, it does not. I tried it yesterday. We can't just do basic multiplications like that. That's why I had to create specific terms here for mult acceleration and stuff like that. That was something I actually found kind of weird. That it didn't have. Okay, so we want to do mult. And I'll show you in just a second. Let me just do dt times 0.5. Just let me go ahead and put this in this current format, and I'll show you that the other one doesn't work. Actually, should this compile? Isn't glm a C library? I think it might be. I'm not actually sure. So velocity times dt? Yep. So this one, for example, wouldn't work. So let's do mult of velocity dt, and then molt of 0.5 times dt. And I did this again wrong. I think acceleration should be first. And then we have that done there. Okay, and I think this should do it for now. Then we have to do a different calculation. So let's go over here and let's go into VI source. Include aux functions. Pop down here to the bottom and just add in the glm vec3 molt and do glm vec3 vec3 what did I call it? Vec and double val. Make that. Let me see. Maybe try with a float? Yeah, we could try with a float. Oh, I misspelled Verlet. Let's go up here, write this, go over here, make that. Okay, seems to make, just to be clear, so let's do, just down here I'm going to say, since we have the acceleration, let's just say acceleration times equals 1.0. See what happens. Make that. Oh, that one did work. What if we do double? Make. What the heck? Why is this working? It was not working yesterday. Why? I'm kind of confused here. Let's do. I swear, we had like all these errors when we did it yesterday. Yeah, this is the same error. Okay, there we are. That's the error we had. So let's change this to a float. Yeah, we're getting the same thing. So mismatch type. Let me see. What do we have here? Up to the top. Actually, let me just clear a couple times. So Control LLL. Make. Hey Borox, what's up? It's been a while. I'm not gonna lie. I've been streaming this week, but it's been a while since I've been streaming consistently. 1 second. Let me go up here to the top of these errors. It says no match for operator star, and it says float GLM precision. So do 1.0 F. Yep, I can try that. Make. Yeah, okay, that one works. Fine, fair enough. So we could just use that. And since we're doing visualization here, I think floats are probably good enough. Yeah. Okay, so let me try something else then. Let's do. Okay, so then, if we cast everything to a float, it should be okay then. And we can do this in another way. And that's okay. It's like the same for me with DB visualizer, my MySQL Workbench. So much nicer to be able to visualize the results in a GUI rather than invoke a session MySQL shell from the distance. The fact that I can run my stuff on a work machine with a GTX site next and have the notebook environment on my laptop or home PC is great. Yeah, it's quite nice. I do this a lot. I like SSH into other things. I think there's a type def for 3D double vectors. Yeah, I think it's okay. Let me see. What did we do with the GL and vec3? I think VI source, GL setup, and it should be. Oh yeah. So we just set them as GL and vec3s, right? So that's okay. We can leave this as we have it for now, and we'll work on it in just a second. So let's work on this now. So to get the Verlet algorithm actually working, we need to first find the Verlet acceleration. But we should actually do that. We should actually do that when we set the parameters, I think. So this should be done once at the very start of the simulation, and then it shouldn't really be done again until the middle of the time step. So I think what we can do is go ahead and pull this here and put it down. Let's see, what do we have here? It should be, we calculate the positions first, then we calculate the velocity afterwards. So we should put the accelerations here, and then we do dd and paste here. And this should be one of the possible methods, 1/2 at squared, find Verlet whatever, and then we say acceleration is equal to this guy again. So we pull it from the function. And that should do it, I think. This is kind of messy. I'll fix it up in just a second. Let me make that. Especially because, so let's do SciVL and do -s Verlet. Oh, it's not moving. Great. Okay. Let's put, why isn't it moving? It's not moving because, make that guy. Let's see what we got. Yeah, its current positions are always the same, which means the acceleration is going to be equal to 0. Ah, fair enough. Let's put this down here again. This means we have to find the acceleration twice, which is kind of a bit of a pain, but that's okay. No, it's still not moving. What? Oh, did I not make it? Probably didn't. Run that. It's still not moving. What the heck? Why is it not moving? Okay. Probably my molt function, actually. I'm sorry. What did I miss something? I apologize if I missed something. The notebooks and then moving to regular Pi file. Are we talking about the Jupyter notebooks? Sorry about that. So I did comment, I thought. Wait. Oh, no, I missed something. Yeah, I totally missed something. dvec3 if you want to use doubles. Okay, well, everything's kind of set for vec3s. dvec3. Yeah, fair enough, I guess. Let's see if this is a problem with my molt functions here. Plus equals. Oh, part of position shouldn't be plus equals. It should be... No, it should be plus equals. Yeah, I think you guys are right. I think floats would be enough, but that's good to know that it's dvec3. V of t, x of t plus delta t is equal to x of t. Yeah, that should be okay. V of delta t plus 1/2 at squared. Yep, that should be enough. Okay, so let's do this then. And see if that does anything. Oh, I forgot to multiply sign. Make that. No, it still isn't moving. It was just moving a second ago, I promise. Okay. Let's see. So if the positions aren't moving, this means the acceleration is probably 0 and the velocity is also probably 0. But we know the acceleration finds something because it was working just a second ago. Okay. So find velocity acceleration here. Let's go down here and let's say acceleration times this guy. And then we want to put a float in here. Something like this. We put some sort of temp position here to set it as a current position. We go down here, we say previous position is equal to temp. Then we go down here and we do translation vector is equal to this. So this means that the temp position up here, basically the position is not changing. So this would mean that we have the velocities here as the same guy. So let's go down here and let me output something just to check. I want to do well, one thing could be the problem. Par.v3 map of velocity. I know, I don't like these maps either, equals vel. Make that. I have a coworker that doesn't really know programming, but the notebooks allow for her to change some variables to run certain tests, which would be a pain in other environments. Wait, I'm totally missing like everything. So they are great for that. Husky, I generally use notebooks to learn my way around some of the modules I wish to use for an app. 9-year-old Slayer Darth. Yeah, I'm totally missing like the entire conversation. I'm doing awful with this today. I'm sorry about that, guys. Okay. Let me just run this, see what happens. Run. Okay, it is moving. But very, very slowly. Yep. Okay. Why? Read that one. Okay, it is moving though. Let's do... Oh, wait a minute. Let me do a quick git diff of, yeah, okay. I think I had something wrong last time. Let's go into VI source, distributions.cpp. Let's go down to Verlet par, and let's change the time step to something more reasonable. Go over here, let's make that. And then let's do Savile as Verlet, and we should see, yep, okay, good. The object is moving. Here's the issue. Okay, so before, we were doing dt instead of dt squared. So like when we were doing the acceleration term, it's supposed to be 1/2 at squared, because it's the Verlet algorithm, it was supposed to be at squared, but we were just doing at, right? However, because we set dt to be equal to basically dt squared, right? It was 2 orders of magnitude smaller. It was all okay. There wasn't really that big of an issue. So let's go ahead, slow this down just a little bit more. Make this go into VI source operators. I'm sorry, wrong one. VI source aux functions. Go down here and let's change this so we no longer see out this information. Make that. Take a look at it and we should see this guy move down there. Yep, that's exactly what we see. And if we increase the mass of one of the objects, let's increase the mass of, I don't know which one. Here's the Verlet OGL. So let's increase the mass of the upper right hand one. Wait, that's not correct. Oh, I'm not using that, am I? Verlet OGL. Yeah, let's increase the mass of this guy to 10, so it's 10 times the size, just to make sure that the object is tracking the most massive object in the simulation. As for lay, okay, let's do 100. Make that. Yeah, okay, there we go. It's moving that way. Fine. Okay, so let's clean up some stuff a little bit and then move on to the next bit, which is going to be maybe more difficult. I don't really know. Okay, so array is here. However, we should have positions, par.positions. We should be able to change this to par.positions. Oh, sorry about that. All of these should be able to change to par.positions, so we can remove the array from this, this guy. So let's change this to par.positions. And, oh man, is that how you spell position? No, it's not. Position. There we go. So I'm just going to yank until the bracket or whatever, and I'm going to paste it before here. And I'm going to do the same thing here. Ah, dang it. So yank until the bracket again, paste it before there, and then paste it here. Now when we make this, it should basically be the same simulation we saw before, and we should be able to go from there. Positions with an S, because notation. Make that. And we should see the same thing. Oh, nope, we did not see the same thing. Why not? What? Why did only one object show up, and why was it this one? Let me see. Part.position 0. Wait, why was it that one? That one is the array 1 that's working. Let's pop down here and let's see. So we say part.positions push back. We should see one in the upper right, the lower left, the lower right, and somewhere in the upper left. That's what we should be seeing. That's what we have for the part.positions. And this is because... Okay. Yeah, I know why. Yeah, okay, fine. Let's keep this as array. Go down here, change all these again. Sorry about that, guys. DT bracket. There. There. Array. Here. There. Here. And change these guys up here. I know this is kind of silly, guys. I apologize for that. Par.positions of 0. Put it here too. There, there, and there, there. You're wasting more of your own time by programming that. Oh, programming on that machine. Yeah, you're talking to Slayer Darth. Yep. Change these to 1, R1. Change this here. Change this to 2, R2. Change it here. Change this to a 3, R3. And then go there. Write this, go over here, make that, and this should work just fine. Or not. Invalid static cast from... Wait, what's the issue here? Distributions.cpp 7. 7? I didn't do anything with this one. glm.hpp. Write this, go over here and make G. G. These all should be GLM vec3s, which should be floats, should be okay. I bought a sweet Asus Ultrabook for like €600 during the last Black Friday. Normal price is like 1,000, but Linux on it works like a charm. Yeah, fair enough. I mean, that was what happened with my first computer too, something like that. Invalid static cast from float glm precision 0. Why doesn't this one work then? Oh, why don't I just do this? I am using floats pretty much everywhere, I think. Okay, how about I do this then? We're gonna say array is going to be equal to par.positions. And that should do it. So let's go ahead and remove these guys here. And now we say for int I equals 0, I less than shapes, par.shapes as size. Then we do plus plus I. We say array of I of 2 is going to be equal to 0.0. Basically, you need to set the z coordinate to 0 because I was being kind of cheesy earlier. And now let's run that, and we should see, why do we only see that one? Come on. Why? Why do we only see that one? That one doesn't make any sense. We should see... Yeah. 1 second. I mean, this... Create circle takes... yeah, it was why I had the error before, but... it shouldn't matter in this case. Because they're all vec3s anyway. Why is only that one showing up? We have par.positions pushed back here. This is the only one that's showing up. Well, this one and this one are showing up. These guys are not. But if I change them to 1.0, I bet they will. Like that. Yeah, okay, they all appear. Granted, the order isn't quite what I expected. So, let's see. Yeah, it should be okay. Okay, those all appear. But I should be setting the final element. Yeah, so like, if I do this as 10, and this as 10, right? They're not appearing because that's technically the z-axis. I probably should have done this differently, and in fact, I know I should have done this differently. But I kind of just decided I would keep the mass there since this is a 2D simulation. Okay, let me drop the air conditioner real quick. There we go. Okay. So, what do I want to do then? I can create an additional map for the... I don't want to create an additional map. It's such a pain. I don't like maps. Okay. So let's see, what do we have then? let's just do std cout array of I 0 new tab array of I 1 and new tab array of I 2 new line. Pop over here, make that. And let's go to Cyvl S. Why didn't you appear? Make. Oh, probably because I don't have anything shape.size. That would explain why we have the issue. Yep. Okay, great. Okay, so what I need to do then is part.positions. Oh, good, good. Part.positions.size is a thing. And this should do it. So let's make that. And now we should see all the objects appear. They're going to be weirdly sized, but that's okay. Yep, good. Good, good, good. So let's pop down here. DD there. And now I want to put these guys in the appropriate size. So what do we have here? We have 1, 1. So this is going to be the upper right. That's going to be the lower left. The next one's going to be... Yeah, let's change this up. So let's do upper right, lower right, lower left, and now let's make that. Verlet, there we go. So that's the order I think we had before, or something like this. And that's actually pretty close to what I wanted. Great. So if we increase this one by maybe 10, go down here, let's make that. Cyvl, and then we let this guy run. Oh, actually that one didn't work. Let's change it to 2. Make that. Cyvl Verlet. Yeah, there we go. That's perfect. Great. Great, great. Okay, good. That's all I wanted. Been looking at laptops too. The thing that annoys me is how few laptops have good CPUs without dedicated GPU. I understand the reasoning behind it. The current Asus works great with Linux. I don't have experience with Lenovo's and Linux, but I really don't need a GPU. Wait, what do you mean you don't need a GPU? How are you supposed to do GPU computing without a GPU, you know? Okay, so this seems to be working okay. There's a couple things we need to add in. So since we have a velocity Verlet algorithm, let's just go ahead and shoot this guy a little bit and make sure it works. So we're going to give this guy a bit of an acceleration in this direction. So we're going to give it 0.1, we'll say. See if that changes anything. So it's initially shot in the X direction just a little bit. So let's do Verlet. Okay, that didn't seem to do anything. Let's do 1. No, that doesn't make any sense. We shouldn't do 1. 0.5. Make that. Cyvl Verlet. Okay, so what happened there? We should see the velocity should be changing every time step based on its previous time step, right? So let's go into aux functions here, pop down here, and let's see what we have. We say velocity is equal to par the v3 map velocity. That's okay. We then say down here that velocity plus equals acceleration times dt times 0.5. I don't see a problem with that one either. Oh, except for the fact that no, that should be okay. Because, for example, if the acceleration is always 0, which is okay. Link for the music. The music is directly under my stream. So here's the stream. Just go to info, scroll down. There should be like Josh Woodward somewhere in here. Music. Nope. Here. Right here. There you go. Okay. So let's go from here. We know the velocity seems to be doing something, but it isn't doing quite what I was expecting, right? I was thinking, Right, so if you give someone an initial velocity in some direction, we should be seeing it move in that direction for a little while, right? And according to our part.positions here, it's plus equals velocity here. So I think that we're just overwriting velocity somewhere. Let me see. Can you, wait. Thing is, I would be fine with just, can you like zoom in and out to observe from a bit more? Could. Maybe, oh, MB for not looking. Oh, my bad. Yeah, don't worry about it. It's okay. Okay, so let's see. We have vec3 translation, which should be okay. And then we put the velocity back in over here. The velocity, the only time we change it is we say it's plus equal to acceleration times float here. And that should be the only time we're changing the velocity. Here. Yep. Next. Yep. And then we store it afterwards. So let me just see how the velocity is changing over here. So let's do par dot, let's just do velocity. Index, probably don't need that. It's probably just velocity 0, velocity 1 should be okay. And let's see what's happening. So let's do make and run this guy. It's IVL, and looks like starts with a, oh actually no, this looks probably about right. It just, maybe we just need a much higher velocity for this to work. So let's go ahead and pop this over here, right quit, and go into, oh, it's because the time step is so small. Yeah, that's fair enough, because the time step's so small. Okay, I'm up with that. So let's go into Verlet par. Yep, there we go. And change the initial velocity in this direction to like 100 or something. 10. Go over here. Make. Gusturn. Oh, I misread your original message. I thought you wrote that you needed a better GPU. What about high? Actually, I read that too. Yeah. Oh, without it. Yeah, okay, fine. So let's go into Saville. Oh, there was, right over there. Did you see it? You probably didn't, because who sees that? Okay. So, now what do we need to do? We need to change this up a little bit. So now what we need is some way to shoot our object, right? So based on how hard we press the space button, we should be able to go from there. Yeah, so actually I had music yesterday. And the day before that. So I had music the day before that, and it was very, very quiet. Then I had music yesterday, and I thought it was a little bit too loud, so I put it just a little bit quieter. So let me know if the volume's okay, you know? You guys should still be able to hear me no matter what. But if you guys want it higher or lower, that's your call, right? I don't want to put it incredibly high, because I don't want it to be, like, the only thing you guys hear, but at the same time, it's nice to have some background music, in my opinion. So, okay. So I think this worked okay. The problem is that, pop down here. Let's remove these keyframes. Go here and make that. And let's go to Saville Verlet. There we go. Okay. So the issue is, because we're just shooting this object at any given moment in time, right? So it's shooting basically before it's visualized. So it's moving before the visualization occurs. So, we want to be able to choose when it moves and when it doesn't move. So, what do we want to do? I guess we want to say, distributions.cpp, Verlet, par. And we want an additional Boolean in here. So we're going to say par.bmap. And I guess we'll call it, move, or something like this. And we're going to set it initially equal to false. Okay. And what we want to do then is we have these keys up here, and we're going to put a switch case for a particular key, which we'll do in just a second. So now we should do in aux functions, pull down here, and basically wrap this whole thing up in a loop. So we say if par.bmap of move. I know it's kind of a silly name. I apologize for that. Then we go down here and we say that, add in a couple spaces there, and just do it for all of these guys. There we go. Right there. And we should be okay to go there, I think. We can also probably get rid of this guy. So let me go into distributions again, and let's do Verlet par. Okay. I really like the new ThinkPad X1 Carbon, but it's overpriced. Yeah, maybe. I don't really know much about it. Actually, no, I think that's the one my roommate said he wanted to get. Oh man, I've been doing Python apparently. And let's make that. Okay, so it should be true. I'm just checking to make sure this works. So let's do Cyvl s Verlet. Yep, okay, that worked. And now we want to set this to false. Let's make that. And this one should have no movement whatsoever. Cyvl s Verlet. Yep, no movement whatsoever. Now let's go ahead and add in the key to allow us to shoot the ball in whichever direction we want. And let's lower this to maybe 1, just to make it a little bit less obvious. So what do we want here? We want different keys here. So let's see, I should have space somewhere in here. Yep, SDLK space, just checking to see what it was. And let's go down here to Verlet key. Here. And we're gonna add it probably here or something. If is down, I think. Something like this. How did I do it before? Let me see. Key if is down. What do we have here? If is down. Where is this is down stored? Oh, it must be some sort of global variable. I don't know. I don't remember how I set this. But let's see what happens. I'm just gonna do this. Just to start, I'm gonna say if is down. Where are we? Keys. Car.bmap of move equals true. Make this, see what happens, and we're gonna give this guy a run. So we should see nothing moving, and then we see it moving. Great. Fantastic. Okay, so now what we want is 2 additional keys, which allow us to move it up and down, and then 1 additional key, which will allow us to charge the velocity. So let's go ahead and add these guys in. We probably want to add some spaces. There, there, and there. And now let's do case SDLK up. And we're also going to want the same for down, but let's go ahead and set the up case first. Come on. There we go. Let's just go ahead and grab this condition here. So y3y, paste it down here. And we're going to say if is down. We are going to move the shape up and down a little bit. So we want then index equals par.positions dot size -1. Again, I'm kind of hacking this a little bit, and that it's not exactly the cleanest thing, but that's okay. I'd probably go with 15 out of the 2 of those. Yeah, actually, what do you guys think of small laptop screens? I'm 50-50 on them. I like small laptops, don't get me wrong, but I think 13 inch is probably just a little bit too small, you know? I agree with what Gus says, but then again, you can always just plug into an external monitor and you don't have any issues, you know? I don't know. Anyway, so par.position size, and we say par.positions dot positions is perfect for my case. 15 is too big. Oh, actually, what did I do before? We have platformer animation keys or something like this. Left. Par.shapes dot vertices 0. Move left equals true. Oh, I had parameters to move left and move right. 15 is too big, it's too heavy to carry? Yeah, it could be. Yeah, I think so. If I use the laptop as a desktop, I would prefer 15. I see. Yeah. Yeah. So for me personally, I used to use my laptop as a desktop. I don't have them around, but I had like this big old 15-inch laptop. Then I turned that to a 14-inch laptop. Now I think I have a 13-inch laptop. I don't know. I'm successively getting smaller and smaller. But really, I just use the laptop to SSH onto another machine, right? So it's kind of like, why even use it to begin with, you know? I don't know. It's one of those things I haven't quite figured out the best way to do it. So let me pop down here and let's create 2 other booleans. So let's do Verlet par. And let's do paste, and we want move Let's do up and move down. And these are all going to be false. Okay. Like we use laptop as a desktop, prefer 15. Yeah. Okay. 13-inch. So pretty much everyone now likes smaller laptops. That is fair enough. Okay, so we're going to say move. Actually, let's just do it this way. Par dot bmap of move up equals true. And then we're going to say else. Come on, I can spell else. And we're going to do the same thing here. So yank paste equals false. Okay, now we have to grab this guy. So for 7, yank 7 yank, paste it down here, and do the same thing for down. I'm going to wait. What did I? I'm going to kill your old. What? What happened? Oh yeah, the missile over Japan. This happened a while ago. I'm in Okinawa. Like here, let me show you why I'm not worried about it. Let me go here to move down, and this to move down. Okay, like yeah, I am worried about it. I'm worried about this whole North Korea thing. Oops, sorry about that. Let me just go to Google Maps. They sent a missile over Japan. This happens actually quite frequently. Here. And then we should be... Okay, here's Okinawa. I'm somewhere in here. Okay, here's Japan. Alright, so first of all, to get to the lowest point in Japan... Oh, actually, let's say to get to Tokyo in Japan, that's a 3-hour flight. Alright? They sent a missile over here, northern Japan. So, we're talking about like, you know, almost 7 hours away. I mean, for comparison's sake, let me just zoom out a little bit. This distance here, from where the missile was, is about the same as this distance here. You know, so we're talking about almost most of the US being changed, going from there. What do we have here? Yeah, it might happen. Look, I'm not a big fan of this whole North Korea thing. I mean, why Trump provoked them? I don't know. It just seems... Yeah, it seems bad. I just don't understand why a world leader of the United States would do what he did, but hey, I'm not a world leader of the United States, you know, so what do I know? Crazy thing that Finland and North Korea are only separated by one country. No, Okinawa is in the south. It's the southernmost point in Japan, because you are an island, like, really, really far out in the southern, like, we're the closest to the equator you can get, as a Japanese province. Okay, so now I want to go into VI source and aux functions, and I think we have VI source and platformer, and I think what I can do, we should have, it's kind of messy, I apologize for that. Let's see. We have a bmap to move left and to move right. That should be okay. So we say move shape. Yeah, this should be okay. So we basically want something like this. We want smooth movement, right? So instead of doing what I was going to do before, which is just move the object up and down by like 0.1 or something like that, what I'm instead going to do is flip a Boolean value up and down, and when this Boolean value is true, we move the shape. Otherwise, we do not. And this, I think, will help us out a good bit. So now we want this as else. So this is before we're allowed to move our object. We'll say if par.bmap of move up equals true. We don't really need the equals true. We can probably just leave it here. Pop it down here. And now we basically copy what we have over here, so let's just do that. And close this. 1, 2, 3, 4. Is that 4? Yeah, it's probably 4. Okay, DD that line because I don't like lines. Change this to 0 and 0.1. Okay, we're going to move the shape, and this time it's going to be par dot, should be par dot shapes. So let's go ahead and find the index. Index is going to be equal to par.positions.size -1. And then we're going to just do par.shapes index. Here, dd there. Par.shapes 3.draw equals false. Nope, we don't have that here. Par.dmapx, we don't have that here. But we do have par.positions of index plus equals trans. And that, I think, should do it if we make it. What did I miss here in the chat? I think I missed some stuff. Trump is a narcissistic moron. That's why he brags and provokes. There's no real reason for it. There's no strategy or anything like that. Yeah, but... yeah. The new communications director of the White House is a former Ralph Lauren model. Fish? Wait, who's Ralph Lauren? I actually don't know who this is. Obviously no. Obviously she earned the job on merit. Well, I mean, you have to... yeah, okay, fine. I'm not... the one thing that gets me about Trump... there's a lot of things that get me, but the thing that I just... man, I just cannot get behind is his just distrust of scientists and hatred of like pretty much all things good, you know, like everything about the environment and everything. It's just like, why would you I don't know, he just doesn't like the environment, and that's the thing that gets me. Like, I think I'd be okay with it if he was just a stereotypical Republican, but he actively goes against pretty much everything that I guess millennials, at the very least, find attractive in society. You know, like he just tries to get rid of everything that we had hoped for, or people in my generation had hoped for. I don't know if I necessarily agree with what all millennials say, but you know, whatever. So let's go into Cyviel Verlet. Okay, the object's not moving, but if I press space, he's still moving like that. That's okay. Okay, so this means we're not moving the shape appropriately. But that's okay. We'll figure that one out. What do we have here? I hate... I'm running for president. Yeah, fair enough. Let me see. I thought you were a millennial. I think I am. I don't really know. I mean, I know I am 25, I think, right now. So I think technically that's the bracket I'm in. Okay, so this means... we should be seeing the shape move here, but we're not. Go down here, make that. Yeah, I know that guy. Good, okay. So we're definitely in this loop. If par.bmap move up, let's make clean. I don't know, sometimes just making clean helps it. If par.bmap move up is true, did I do something wrong before? Anyway, here's the translation vector. Here's the index. Move shape par.shapes index. Par.positions index plus equals trans. This should work, I think, unless I'm doing something wrong. So let's go into distributions. Let's go into Verlet key. Move up true, move up false. Should be okay. Yeah, I recognize the streamer, by the way. You were the sort of millennial who got pissed off when they couldn't get Arch installed for the first time. Yeah, fair enough. I mean, Arch, I like Arch. I really do. Maybe it is Stockholm Syndrome in some way, but I really like it. It's a lot of fun. I wonder how much gigabytes of RAM it has. My laptop? Oh, your Arch laptop. Yeah. Let's see. If is down, move up. Okay, well, let's try something else then. Aux functions. Pop down here. Let's just output something if we're pressing the up button. Because why not? Make that. And let's do... Didn't you say you have 32? I think I have 32 gigabytes of RAM. What up? Great. Oh, but it's not stopping. Okay, maybe it should be stopping? Yeah, why is it... Ah, shoot. It should be stopping. Okay, so this means... Okay, first of all, the object's not moving up, which is a bit of a problem. it should be moving up. That's totally true. Okay, so now let's go ahead and DD here, and let's see why it's not stopping. So let's do distributions.cpp. Let's go down to platformer. Next. Platformer key. Did I do something stupid here? Is left. If is down. Move left equals true, else equals false. Oh, I forgot a break. That's something. Break. Do the same here. And there. And of course, I forget semicolons because, you know, I'm new to C++, guys. I've never used it before. Okay. Make that. The lap I'm using right now has 4 gigabytes of RAM. Really need to buy at least. So let's do this. This probably shouldn't solve the issue. Oh, it did. It did solve the issue. It moves up now. But it doesn't move down. But it does move up. Nope. Now it doesn't work anymore. It did it once. Move up and move down. Move up. Wait. If I press down? Okay. What? Okay. Run this. I press the up key once, and it moves up continually and doesn't stop. Alright. That means this... this is down thing isn't working the right way. It should be if it is down, it moves up and down. Oh, I see the problem. Okay, it moved up. Okay, let me try. Yeah, okay. We're almost there, guys. We're pretty close to where we need to be. What I need to do then is figure out why. Let me go into the platformer guy over here. Let me see. VI source. Platformer. And we should have a move left and move right. Somewhere in here. Yeah, move right. Okay, equals true. Let me see. Hey, Romania Hate, what's up? So we're going to do here. Aux functions there. So we turned it to true. If you press up and down afterwards, both move up and move down are true. Yep, that's why it stops moving. However, it should be that it turns false when I'm not pressing the button, right? That should be the case. However, it doesn't seem to be the case. And I don't exactly know why. So what do we have then? Move left equals true. Yeah, that should be okay. That shouldn't be a problem then. Where's the Fortran? Yep, where is the Fortran? That is a good question. It's not here. I don't know why I just made clean. It's just something I did. I haven't used Fortran in a while. It's one of those languages I really do enjoy using, but I don't know, I don't get the opportunity very often, you know? Okay. Let's try it one more time. I don't think this will do anything. I just felt like, yeah, it's still doing the same thing. Okay. Fortran. The more I say it, the more it sounds like 4chan instead of Fortran. Okay. Verlet. Par. Oh, key. What do we have then? Up. If is down, else move up equals false. Last time I saw you did some physics light simulation in Fortran. Maybe, but that was a super long time ago, like almost a year ago, I think. What do you call a messaging forum for programmers? Fortran? Maybe. It's also a language for physicists. Okay. So let me go up here to my platformer guy, which we know is working. If is down, move left equals true. Else, move left equals false. Break. Yeah, I don't like math. I'm sorry about that, man. Okay, so why then? This seems to be the same thing that I have, right? So then, I feel like I'm doing something stupid. Boolean is down is being read in. Let me just see something real quick. So I'm going to go in here, and I'm going to do something kind of stupid here. I'm just going to output std cout, press up. New line. Over here, let's make this. So it should be make. Oh, I'm sorry, I just made it. Here. Okay, if I press up. Okay, it never goes into this false position. No one likes math. Some people are just better at pretending. Kipo. Where is the similar language? I don't have one. I'm sorry. The kids love math. Can't agree more. I feel like math is one of those things that gets a bad rap because it's actually incredibly interesting. You know, there's a lot of things about mathematics that is incredibly interesting. But, I don't know. It's just, I think a lot of people just, they didn't learn math in a way that makes it fun. You know, they learned it in a way that makes it kind of, well, you know, boring. You know, math is considered boring because I think that's what people know it to be, you know? Okay, so let's see, Verlet key. Reads Boolean is down. Let's go into, oops, sorry about that. I hit something. Probably heard that in the whatever. Schools nowadays, I feel like schools forever. I don't think any school in the history of schooling has ever made math interesting. You know, like, okay, I don't think that's true. But I think for the most part, during any era, you go in, you learn mathematics, and it's the one that you don't want to learn, you know? That said, it's also the hardest one to apply in everyday life, you know? You can immediately see English's use. You can immediately see history. You can immediately see science. But it's hard to see the use of math, you know? Except for the fact that it's interesting. It's interesting because it's a set of problems that you can enjoy doing. But, I don't know. I actually enjoyed a number of my math classes, but not because of the teacher. It was in spite of the teacher, usually. I had one teacher from 7th to 9th grade who made everything super interesting. After that, all the teachers were, yeah, I'm sorry about that. I don't know. Okay, so let's go into VI source, GL setup, and let's look for key. Key function there, that's okay. Key down, okay. Sorry about the yawn, guys. Boolean is down. Here. So SDL key up, key down, true, key down, false. Okay. What I want to do. Let me just have an extra guy here. So let's just do another case. We're just going to grab these guys, so it should be yank 7 yank. We're going to move down here. And let's see. Is down is a Boolean variable that we're reading in, and we're going to change this to some random letter, so let's change it to the letter K or something like that. That's probably how you do letters, right? Where's Pong? Let's see, up, down, W, S. Okay, so let's do, Verlet key. There we go. And let's change this to a lowercase key, just because. Arcane. Okay, if is down. And I'm just going to output stuff. Should be std cout is down. Yeah, why not? Is down. New line. And we're going to put the same thing here. There we go. What did I miss? A lot of things can be fun if a teacher doesn't touch them. Yeah, that's totally true. History is actually fun if you don't have to write a test about what you learned. Yeah, I think that's true too. I mean, history is just a conglomeration of stories, right? And if it's not the use of history, to me it looks useless. Besides the learning itself of past events, I think history is fun because history is one of those classes that you learn a bunch of trivia. It's literally learning the stories from the past, and it was one of my favorite classes because you just learn about what people were like for like what made us us, you know, and that's very interesting. At the same time, I think what Buttercake said is true. The moment I'm taught something, the more I dislike it. You know, the more I can't stand being taught stuff. You know, but I enjoy learning things. So I get kind of, I don't know, it's kind of weird. Let's make this, and let's run Verlet. Okay, see, it should be. One. Okay, so when I press down, it says 1, but otherwise it doesn't say anything. Okay, that's interesting. So that means the false condition never appears? Wait. Let me try something else. Let me go to the platformer distributions. Let's go into VI source, distributions.cpp, and let me just go into the platformer. I'm sorry. That was exactly what I wrote. I mean, learning about 17th and 18th century is kind of okay, but why should I learn about some trader guy that set up a state-like organization in the 7th century? Okay, let me tell you guys one of my favorite series on YouTube. It's Extra History. These guys are amazing. I really like them. Let me just go ahead and pull them up for you. These guys have... It's true, though. I mean, these guys do a very, very good job of presenting history in an enjoyable way. Okay, so what I want to do is go down to the platformer. Here. And let's see, we have space. That shoots something. We have left. So what I want to do is pressing the left key. I want to put an additional std cout. So let's do std cout is down. End line. Good. And we're going to put the same thing here in the else statement. Sorry about that. There. Let's go over here and let's run a different distribution here. So we're going to write, make that. Come on, make. There we go. Hey, Gothic Death Eater, what's up? Hashtag deep. National History makes some great content. History is the one thing I just can't get into. History channel. I feel like, I don't know, I feel like I enjoy history a good bit. So platformer. That was not what I meant to do. Here we are. Okay, if I press the left key, 101010. Yeah, okay, it's working here, 10. Yeah, that's totally working. Did I do something silly? Yep, okay, that's what we should see. Okay. Now if we do this for Verlet, and I press the K button, it only does the down, it doesn't do the up. Why would it not do the up? Okay, that's something. Wait, History channel? History is one of... I thought History channel was the meme. I feel like... I don't know, I don't really know that much about History channel if I'm being honest. Why would platformer work? But everything else not. SDLK left is down. My roommate was watching this World War I documentary, and it was quite good actually. It was like in black and white. It was done in 1940s or something like that. I think just before World War II started, and it was actually very, very well done. I enjoyed it a good bit. Okay, let me grab this guy. I feel like I'm doing something stupid here. Let's just pop down here. Here's the relay key. And let me just paste this here. Is there something here that I'm doing that's different? SDOK is down. Par.bmap move left equals true. Par.bmap move left equals false. Break. I mean, I forgot a break. Which I keep doing, by the way. Is down, is down. Everything else looks the same. Let's remove this. Go over here and let's make that. Run Verlet. Yeah, it's only doing the down. It doesn't do the up. It does not do the up event. But I just tried this. Okay, so what else could be the problem then? Why would we only see the down event if is down return? Oh. Oh my gosh. Oh my gosh. Ah. Found out why it didn't work. I hope no one saw that. Oh my gosh. That was kind of embarrassing. Alright, so we're gonna remove this guy down here. Yep. Okay, great. Alright. Move the press up. Make that. Alright, if it doesn't work, D. Okay, let's run that. Great. Awesome. Okay, works just fine. World War II didn't officially come to an end until 1990. You're talking about the Cold War. The Cold War is an interesting thing in my opinion. I feel like I'm gonna move the microphone real quick, guys. I apologize for that, but you're gonna hear a little bit of noise, and that should be okay. Okay, there, it's set. The Cold War is like super interesting in my opinion because it really did change the way the U.S. and Russia and I mean it forced the U.S. into this weird position that it is in currently, where it just feels like they feel like they're more important than they need to be, and they have their hands everywhere. It's just, I don't know, it's really weird. The U.S. went from an isolationist type of country, which was before World War II, to a country that's hands are everywhere, you know? Is the mass simulated like only at the center? Yeah, it's a point mass. We assume it's only a point mass. For now. We can change it in a bit. Okay, so last thing I need to do is case we'll have some sort of charging my laser type of thing, and I think it's going to be SDLK left. Yep, just because why not? If is down, here we go. Yep, should be okay. We should just have an is down command here. We're going to say par dot, what do I want to do here? I guess we're going to say par dot v3 map of velocity here plus equals, and we want it to shoot further in the right direction, so we're going to say plus equals 0.1 0 0. Okay, and I'm just going to check this in a bit. Living in the US, hence why they had to wait until reunification of Germany to sign a peace treaty. Yeah, it could be. I don't know. There's a series there's a series named The Americans that's about Russian spies in the US. I'm sure. That seems about right. Let's increase this by 1. Okay, and then we're going to go down here and say the initial velocity is 0 to start. So where do we have here? Velocity here. Yep, starts at 0. And actually, I think 0.1 is correct. So let's change this back to 0.1. Okay, so what we should see then is if we make this, hopefully it'll make plus equals, we'll just say translation. So GLM vec3 trans is going to be equal to this guy here, and then we're going to say plus equals trans. And why not? We should probably also do the same for right. So let's do funny name of the cockeyed ideas they had for surveillance back in the Cold War days. Oh, it's funny, some of the ideas. Yeah, that's true. Okay, so I mean now you can just basically do everything online. It's relatively straightforward. I mean it's not straightforward, but like it's information is easier to come by now, I feel. Yank 5 yank, paste, and we are gonna do right. If it's down, and we're gonna say trans is equal to negative 0.1, and we're gonna do plus equals. Screw it. Minus, plus, remove this guy, write this, go over here, make that. See what happens. What are your plans for the future? Do you want to get your PhD and become a professor? I'm not doing that, Hemmer, because I'm an idiot and didn't think about just casting it like that. I apologize. Verlet. So if I press space, it just falls to the ground. That's great. Let's try it again. So now I'm going to charge my laser a little bit. I'm pressing the left key a good bit. I don't really know how long I pressed it. Press space. Oh, I did this backwards. And left. I got my left and right confused, guys. I apologize. That happens sometimes. You know, getting a PhD in physics, it's hard to keep track of everything, you know? So now I'm going to press the right key for a bit. Press the space button. Oh, that didn't do anything, did it? Okay, let's try this again. Press the right key for a bit, holding it for a little bit, seeing what happens when I press the space key now. Ah, dang, nothing happened. Do you guys watch Brian Lundgren's videos? He had a guest who's running a business that's going to distribute smartphones with open source hardware and software. I forgot to break this. I haven't seen his show in a while. Okay, what I'm going to do after the PhD, I have no idea. That's why I didn't answer the question immediately. The truth is, I don't know. I mean, let me output some stuff here too. No, I think we should run this. Press the space button. That's what happens. Okay, let's try it again. Now I'm just going to hold the right key for a bit. Yeah, so I don't know what I'm going to do after getting a PhD. I don't know. Oh, there we go. That worked. Great. Wanted to do a pendulum and failed miserably. I also wanted to do a pendulum a while ago and failed miserably. Yeah, so truth is, a professorship has most of what I want. You know, it has the teaching, it has the research, it has everything I want to do. But no, I'm not going to get a second PhD. There's so much stress that's becoming with this one. It's just, I don't know. Lately, I've been feeling like I shouldn't have even done a PhD at all, just because like it's I don't know. It's one of those things. It's just like, man, it's so much stress. Like, I mean, I haven't streamed for 2 months, but then again, I think no matter what I do, no matter what my job would be, it'd be filled with stress. So, fine, fair enough. That's in part my fault. Okay, so now I think the last thing we need is some sort of indicator. Well, actually, let's see what we have here. So we run this, we give it a shot, press the space bar, it just follows this way. Actually, where does it go? Oh yeah, it goes right there. Okay, so let's try it again. Let's press down a little bit, press space bar again. Yeah, okay, this is kind of cool, you know? Okay. But yeah, I don't know. I've just been feeling that there's a lot of stress involved with getting a PhD. And if you guys are thinking about getting a PhD, which I know some of you guys have mentioned you are, just know that it's both rewarding and stressful at the same time. It's stressful because, it's stressful because, I don't know, it feels very self-serving. You know, you're doing research and you know that very few people in the world are actually going to care about this research. On the other hand, it's very rewarding in that you are learning pretty much every day, or you have the opportunity to learn every day. And learning is, in my opinion, one of the most enjoyable things you can do. So it's back and forth, you know? Speckled Lemon, that stress thing, all jobs are like this. Yeah, I feel like maybe that's true. A zoom out? I can't zoom out right now. I apologize for that, guys. Really, it was a double pendulum, one connected to the other, but I didn't grasp the principle behind them. Oh, yeah. I mean, at some point, you lose the ability to use a small angle approximation, and then it gets kind of confusing. The CIA were training a cat to spy on the Soviets, but it got run over by a taxi before it could infiltrate one of their compounds? Oh, that's amazing! Holy cow, that's amazing! Okay. Let's talk about what we want. So right now, we have this thing. We're allowed to shoot our asteroid with an arbitrary velocity. There we go. Great. We probably want some sort of finish line indicated, so probably some sort of line over here or something. Yeah, just to say that's where we want to go. Yeah, I don't know. I mean, I feel like, yeah, this isn't obvious what we're doing, right? And we also probably want some indicator of the velocity. Right, so let's see, how do we want to do the indicator of the velocity? I guess what we want then is like some sort of box over here saying like that's the finish line, and then another box up here with the velocity of some sort. I'm not really sure. Something we have to think about. Also, we're not able to reset this. We're going to do in-body simulation soon, actually. I promise. That's actually one of the next things we want to move into. So I wanted to basically take this simulation and then do something simple for the Verlet algorithm, and then later when people want to do the Barnes-Hut algorithm, we introduce octrees, or quad trees in this case, and then we basically run the same simulation. It's just with the quad trees associated with them, and I have to find a good way to visualize that. But that's something to work on. Okay. I'm kind of a big fan of this. I think it works pretty well, you know. Yeah, okay. I think it's okay. I don't think it's bad. So right now, because we have something kind of working, I'm going to go ahead and commit this to GitHub. So git status, and we're just going to do git add source aux functions. Actually, let's just do source star. and include star. Get status again, just to make sure. Good. And then let's do git commit. Let's see. Git commit, adding the ability to move asteroid with buttons. Yep. There we go. Git push. We're in beta. That's my commit message, guys. Alright, good enough. Give it a second. Let's see. Do you consider yourself an overachiever? Can you let it running for a bit just in case it comes back to view? I don't think it will. Just because of the way it worked. Here's a question. How viable is it to do real-time general relativity gravitation simulation? I don't know what you mean exactly by general relativity gravitation simulation. If you're talking about like the movement of space-time itself, I don't think that would be hard to do in real time depending on what you want to do. Let me see. So let's start at the start. So, fled from nowhere. Do you consider yourself an overachiever or not? No, I don't really consider myself an overachiever. I think a lot of people think I am an overachiever, and I don't know why. I think like I talk to people during the day, and they somehow become very impressed with me, and I don't mean to be impressive. Like I tend to be very dismissive of my own thoughts, and tend to be very how do I put this? Very I don't know, just very down. Like when I talk about my stuff, I usually say like, it's not that great. Like, it's kind of crap. You know, like I say all this stuff. Like I apologize very profusely. I don't know. So I don't exactly know why people tend to hold me in very high regard at all. That said, I do work a lot. So that's fair enough. How many people with physics backgrounds know programming? I would argue that most people with a physics background know at least a little bit of programming. It's one of those things, it's very, very hard to get through a physics degree nowadays without knowing at least MATLAB. And for the most part, you're probably going to be using everything else. Like, you're probably going to be using Python. If you're using physics, you probably know Fortran. But the truth is, the amount of programming principles you know, like in terms of the ability to write clean code, this is not often sought after as a physics student. So you are probably not going to be able to code as well as people who learned in computer science or have years and years of experience. Kind of like me and this stream, right? Like, I know everyone on this stream knows more about programming than I do, so in principle, I kind of feel bad about certain things, but on the other hand, I'm learning and I'm doing my best to learn. So you kind of hit back and forth. Self-critical, you're impressive. Thanks, Fled from Nowhere. I appreciate that. Let me think. Imposter syndrome, yes, that is a huge issue. In fact, my sister was thinking about doing a math PhD. And I just told her, look, there's going to be times when you're going to sit there and you are going to be doing your research and you're going to think it's the crappiest thing in the world, and you're going to present it and you're going to have to present it like it's the best thing you can imagine, you know? And everyone else is going to be excited about your research because you've presented it well, and you're going to sit there and in the back of your head, you're going to know that it's not as difficult as everyone thinks. And if they would just take 2 seconds to think about it, they'd figure it out, and they'd figure out that you are lying to all of them. You know, like, this is the nature of being an academic. You feel like you don't know what you're doing, and everyone else thinks you know what you're doing, so at some point you just go with it, you know? We had a semester programming, Pascal or C, with some C++. It doesn't really matter in the beginning. Oh yeah, that's true. It depends. So I've actually always, so going back to the professor thing, if I did become a professor, there's one course I've always wanted to teach, and it's a course on computational physics. That is just, if I could teach a course on computational physics, that's what I would do. Holy cow, it's just one of those things I've always wanted to do. Okay, so let's see, we've got 15 minutes left until the end of the stream. This visualization, as we have it now, is enough to get the point across. It's an object moving around in space, and I think that's fine. Now the question is, where do we want to go from here? So let's take a look at this visualization. We have the objects. Obviously, we can press the spacebar, make this guy move. It's great. We see the objects moving. We see that they're moving based on some sort of gravitational field. That's great. I find C the most efficient language. It depends, right? There is a lot of stuff to do. Like, so there's a reason not everyone uses C, right? If you want to do something complicated, we'll say, C might not be the best language. You know, it's hard to do very, very complicated things. So, like, if you want to do, I don't know, just like finding eigenvalues and stuff like that, there are libraries that allow you to do this, but at the same time, I don't know. Real programmers code by pushing bits with a toothpick. I feel like maybe, I don't know. C is too high level. We were having some bits of computing theory, data structures, algorithms, and then we were implementing like how to find a root of a function using various techniques. And last thing we did was calculation of the motion of a double pendulum, making animation with NuPlot. Oh man, NuPlot. Love NuPlot. It's that one thing that it's the plotting tool that physicists deserve, you know? Like it's totally a physics thing. Okay, I want to try something real quick. Okay, if I move down a little bit and I press the I pressed the wrong button. I move down a little bit and I press the right key a little bit. I want to see if I can. Oh, that wasn't what I meant to do. Shoot. Come on, NuPlot's great. Gosh, I used it just yesterday. You know, I use NuPlot all the time. It's great. I really like it. I know it's old, like it's the oldest thing in the world, but there's a lot of things you can do with it to make it kind of nice. Okay, so how am I going to do this? What do we want to do from here? So there's a couple things that we have to do from now on. So tomorrow I'm going to update the Arcane algorithm archive with the Verlet algorithm as it currently stands. So tomorrow will be a writing day, and then I'll come back to this on Friday, I think, and we'll figure out what we want to do to make it just a little bit more visually appealing. At this point, I don't know what to do from here. So let me talk about what we can do next. So new page before. Where is it? There it is. Pulling out my fancy doodle board. Okay. So like I said before, we have this idea that I wanted to work on, which is the Arcane algorithm archive. It's just all the algorithms you can think of we put in this book, and hopefully it will be written in a way that's understandable. So the idea is that we hit some sort of weird cadence, some sort of writing style that is in between, you know, accessible but also descriptive. You know, that's what we want, something that is both accessible and descriptive at the same time. So tomorrow I'll be working on that, and we'll put the Verlet algorithm in there. Now this opens up a lot of things that we can do next. We can do the Barnes Hut algorithm, which we've already done on this stream, but we've already done Verlet on the stream. But Barnes Hut is an interesting way to do an n-body simulation. We can also do other force integrators like Arcane or Euler, you know? There's a lot of things to do here now that we've done something straightforward. And this is kind of what we're kind of looking at next. So the question is, where do you guys want to go from here? I think I want to stick to the algorithm a week type of thing so that we constantly have new things to do, and you guys can just pop in and we can learn new things. I'm kind of keen to move to the Barnes Hut algorithm next because it's really cool and really fun. It's the thing that allows you to do n-body simulations really quickly, and it's why I created the scientific visualization library to begin with. It's why I went into OpenGL and all this kind of stuff so that we could do some sort of fun kind of Barnes Hut game, if you will. Like we see all of the n-body objects in our simulation. We have an asteroid moving around. We have a finish line that we want to go to, some sort of goal. You know, just a very simple mini game type of thing. And this is neat because we can do this now with the scientific visualization library. So anyway, that's what I wanted to say. It'd be fun to move here next, but I'm going to ultimately put a poll on Twitter to see what you guys want to do after that. I think we're probably going to close the stream for now because we've gotten pretty far. We did a lot today. We implemented the velocity Verlet algorithm. We got everything working. It's pretty good. But in the end it worked. I had a bug in the function that calculated the changes in the acceleration and velocity. It took me a few hours to over multiple days to find it. Yeah, trust me, I've been there, I've done that. That's how all errors work. So, what I want to say is I kind of want this to work in this way from now on. We have the scientific visualization libraries to do interactive visualizations of all the algorithms we put up on the algorithm archive. Multi-threading on my personal project, no problem. Choosing the right index in an array on a school-related project. Fair enough. The algorithm is only for n-body simulations involving a single large body and multiple smaller bodies with negligible interactions, though, yeah? Let me think. The algorithm is only for n-body simulations involving a single large body and multiple smaller bodies with negligible interactions. No, ooh, nice book on algorithms. Let me take a look at this. Open link. Oh, it's a PDF. Cool. Yeah, okay, interesting. I'll definitely annotate algorithms in Python. Nice. Yeah, I'll take a look at this after stream. The Barnset algorithm, what it does, and maybe I'm misunderstanding what you're saying, Zadison, but what it does is it allows us to do the full n-body simulation, and approximate a bunch of smaller bodies as a larger body. So for example, let's pop over here, new page before. Where are we? If we have a box, and in this box we have a bunch of particles. So let's just say we have all these particles over here. Yeah, I'm just drawing these guys at random, or as random as I can get. Okay, you are this particle over here, but all the particles are moving, right? This guy split into first quadrants, and then it's split further into quadrants over here and quadrants over here until every particle has its own box. And then if you're this particle over here, you can kind of approximate all of these particles that are in this big box as one big object, because it makes it easier for us to do this approximation. So basically it allows us to do n-body simulations in a much faster way. And this would allow us to do some pretty cool visualizations, in my opinion. I'm pretty excited about that. Let's see. The principal difference on focusing only on programming is learning how to do optimizations, which may or may not be useful. Yeah, so Barnset, I think, will be quite interesting. But this is one of the things that we could lead into in the future. We'll see what other people want to do. Ultimately, we're almost there with what we have. I mean, we have all the particles, we have all the positions. All we need to do is put a force integrator over it, which we have done before in both Julia and C++. So ultimately, we are mostly there. No, it's not necessarily only for gravitational simulations. You could also use Coulomb forces on them. You could use any type of big, like molecular dynamic simulations almost could use this. It just depends on how you want to do it. Any particle-based method would probably do just fine. Anything where you have a force acting on other things. So for example, I had a dusty plasma simulation that I did a while ago. We could use the Barnset algorithm to speed up that dusty plasma simulation because it's a bunch of particles interacting with each other. So anything where particles interact with each other would work with this simulation. Okay. So I think that's about it for the day, guys. Tomorrow will be less coding and more writing. We'll be writing up the Verlet method in the Arcane algorithm archive. We'll see how it goes. I'm pretty excited to see how it turns out. And we might also update a few other pages here and there. So tomorrow will be a writing day, not so much programming. I understand if this might not be entertaining for you guys, but feel free to come along anyway, because it should be fun. And then Friday, we'll decide what to do from there. And I'm pretty excited with where we got. So thanks guys so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos when we work on the Verlet algorithm in the Arcane algorithm archive. And that's about it for the day. So see you around guys. Bye.